This video is meant for Mrs. Rose's AB Calculus class. It is on slant asymptotes and infinite limits. Alright, so we did an example in class, and here's another example where we would need to find any and all asymptotes of this function. The easiest ones to do are the horizontal asymptotes, and we use the limit notation as x is going to infinity. So the limit as g of x goes to infinity is infinity because the degree of the numerator is greater on the top. So there is no horizontal asymptote. Well, instead of having a horizontal asymptote, we know we're going to have a slant asymptote because the degree of the numerator is 1 more than the degree of the denominator. And it seemed like in class most people liked synthetic division instead of long division, so I'm going to use synthetic division. And when you do your coefficients, don't forget to put 0 in for x if you're missing the x term. Alright, so we're going to bring down our 2, multiply, add, and then multiply, and then add, and here is our remainder. Okay. So our quotient is 2x plus 8 plus 28 over 4 minus x, and our slant asymptote is the polynomial part of our quotient, so just 2x plus 8. Okay, so we figured out horizontal, we figured out slant, now we're going to do vertical. We know that the vertical asymptotes happen when our denominator is 0, so we're looking at when x equals 4. But you can't just say there's a vertical asymptote, you need to use calculus to prove it. So we're going to take a limit as x approaches 4 from the left to right side, it doesn't matter, of our original function, which was 2x squared minus 4 over x minus 4. And when you plug in something like 3.9, we're going to get a positive number divided by a negative number, so this is going towards negative infinity. Therefore, we have a vertical asymptote at x equals 4. Alright, now let's do one more example. Okay, this one, again, we're going to start out with an infinite limit, and if we take infinity and plug it into all of here, the degree of the numerator is larger, so that limit is infinity. Therefore, there is no horizontal asymptote for this function. So then the next thing we're going to look at is our slant asymptote. And again, I'm going to do either synthetic or long division, and since we did synthetic division last time, I'm going to do long division. We need to figure out what do you multiply x by to get 2x squared, and of course that's just 2x, and then you multiply 2x times x plus 3. Then we subtract their product. So that's obviously 0, and negative 16x minus 6x is negative 22x. And then you bring down the 19, and you try to look at how many times is x going to negative 22x, and that's obviously negative 22 times. And when you subtract that, we're going to get 85 as our remainder. So our quotient is 2x minus 22 plus 85 over x plus 3, and our slant asymptote is y equals 2x minus 22, the polynomial part. Okay, so we've taken care of the horizontal, we've taken care of the slant, now we're going to look at the vertical. Now we know it's where the denominator is 0, but we need to show a vertical limit with an asymptote, sorry, vertical asymptote with a limit. So let's do that. Okay, so it doesn't matter which way, left or right, that you take. So when you maybe plug in negative 2.9, that's going to be negative infinity. Therefore, we have a vertical asymptote at x equals negative 3. There you have it. There are all your asymptotes. For the full set of notes, please see the PDF on Edline, and I'll see you in class.